Alright guys, how's it going? Here we go. We're going to do a couple of videos on graphing systems of inequalities for you here. Before we get started, there's definitely a couple of notes or a couple of things that you should know before we are able to graph these inequalities. So if you remember, an inequality is when you have those greater or less than signs, right? Like this. Okay, it could be less than or equal to when it has the line underneath that, or just straight up less than when you have no line underneath that. And that's kind of a big clue as to what kind of line we're going to make and which way we're going to do some shading. So let's start with some notes here. So the first thing is when you have something like this, some equation where you have y is greater than or equal to, or just y is greater than, okay? So these are showing greater, and I know this because I like to say that we are eating the y. Okay, so when you eat the y, and we're going to shade up, okay? So if you're eating the y, you're going to shade up. Now shading up is shading towards all positive numbers, okay? You're shading up, you're moving towards all positive numbers. When you have y is less than or equal to, or just y is less than, you are not eating the y and you're shading down. Okay, you're shading toward negative numbers. And the only time you're really not shading up or down is when you have x equals lines or y equals lines, and that's why I like to say, so if you had an x equals line, you shave positive, so that's going to be going to the right, because the x equals line is the vertical line. And if it's less than, you're going to be shading towards negative numbers, and that would be going to the left. Okay, that's just your one special case there. Then there's a certain line we have to make. So if you had y is greater than or equal to, or y is less than or equal to, we are going to be making a solid line when we're graphing it. And if you had y is less than or equal to, or y is just less than, we're going to be making a dotted line. And when we start to get to an example, you'll kind of see what I mean when we do those. That's what the solid line would look like, and that's what the dotted line would look like. Now, the question is, well, what's the difference, or why is there a difference, and what's the difference between graphing systems of equations and graphing systems of inequalities? And for me to best explain that, let's just go back to something that you did a way back when. Say you had x is greater than or equal to 8. On a number line, what you have is the x values can be all numbers that are greater than or equal to 8. So when we first learned it, we said x is equal to 8. There's only one value for x, and that's it, 8. Now, when you started to get to that greater than or equal to, that's when you started that shading stuff. Okay, so greater than shade to the right. So x could be 8, x could be 9, x could be 10, x could be 11. Or you can have a question like x is less than or equal to 8. So here's 8. Less than shades towards your negative direction. So x could be 8, x could be 7, x could be 6, and x could be 5. So that's kind of why we have inequalities, and the same thing's going to happen when we graph these inequalities. There's going to be more solutions, okay? Now, what happens if I gave the same question, but it just said x is greater than 8? Well, what's the difference? Well, when you make that circle, it would be an open circle, but it's still going to get shaded to the right. But we have a difference, okay? Here's an open circle, and here was a closed circle. The closed circle here is telling me to include the 8 because it's equal to. This open circle is saying, well, don't include the 8. Start with all the numbers that are greater than 8. So say 8.1, 8.5, 9, 10, 11, 12. X is less than 8, same game, okay? It's still all of those numbers that are less than 8, but you're not including the 8. And the same game happens when you're doing the graphing part. When you have that line, when you are equal to, we're going to be graphing with a solid line. So if I see a solid line, I know I'm including those points. But when I have a dotted line, I'm not going to include those points. And I'll show you those when we go into our first problem. Okay, so that's the major difference, and that's kind of how you'll be able to kind of figure out what we're supposed to do with these inequalities. So here we have two equations, and if you saw the last video on graphing the systems, it's real easy to do. You just throw it into your calculator. So I would go over here to my calculator, I would go and turn it on, and in my y equals, I would throw in negative x plus 2, and then over here I like to put fractions in parentheses. A lot of the times it doesn't really change, but every once in a while it does. So if I have that idea of always doing it, remember this was from an old question, Zoom 6 always kind of brings us back to that 10 by 10 grid. And there's our system, okay, of graphing equations, but these aren't equations. So when I actually go to start graphing these, it's going to end up being a little bit different. Okay, so I'll leave that up there. Remember, you can go to the table here, second graph, pick any 3 points. So I'm not going to pick 2 because it's got a decimal. So I may pick 3, -1, 7. I'll pick, what is this here? I'll pick 6 and 9. I can go over here to some negative numbers and pick 0, 2 with 5. Whatever numbers you really want to graph your equations here. But I'll just go ahead and graph it from here. So we have 1, which is negative x plus 2, which would look something like this. Okay. Now we have to pay attention. Here we said, like I said, eating the y means I'm going to shade up. And now you notice it says y is greater. There is no line underneath that, so I know it's going to have to be a dotted line. Now I'll sketch this here, but you should definitely try to use a ruler or something straight, especially when you're graphing these, because that point of intersection a lot of the times is important. Okay, before I shade, I just want to make sure, okay, let's write his name here, and this says to shade up, right? Now what's the point of this? Well, if I just went ahead and graphed the line, right, or any line, say it was a solid line on a 10 by 10 grid, any point that you pick on this line is considered a solution. Here, any point or any number I picked on this number line here is a solution. Any of these points here that are not in this area is not considered a solution. And it's kind of the same thing here. Any point you'd pick on the line is a solution, but this says greater than, not equal to. So any point that you pick on this line is not a solution. But any point you decide to pick in this shaded area is a solution for that line. Now let's go to the other one. Y is less than 2/3 x plus 5. So maybe you went ahead and you picked your own points. Okay, now this one here is going to be shaded down because remember, eat the y, shade up. Here I'm not eating the y. And I'm going to go ahead and make a solid line. And it's going to look something like that. And if I look over here at my graph, it's the same thing. Now this here is going to shade down. Okay, so here, shade down. And it's kind of the same thing. Any point you go ahead and pick in this shaded area that I did in red is a solution for this line. Now in this one, yes, you can pick any one and it can be a solution. But now this question here, since it's a system, it wants to know what is the solution for both lines. And similar to here, say that point of intersection is a solution for a system of equations. For a system of inequalities, it's that area where the two shades come together. Sometimes, not always, the point of intersection is a solution. In this case, it is not a solution. Any guesses why? Because this is a dotted line. Dotted lines, the points on a dotted line, do not count as a part of the solution. So this could not be considered. But any point that you went ahead and picked inside this area here would work for both equations. And that pretty much sums up how you do a system of inequalities. All right, let's go to another one here. Same question, just a little bit different because now, in order to graph or in order to solve for y, you have to, or solve for y, right? So I'm going to move this 2x to the other side. Remember, you can't combine these and call it a negative 5 because they're not like terms because of the x. So it becomes negative 2x minus 3. Now you go ahead and divide everyone by 3. So if I put this in my calculator, and remember math, enter, enter gives you a fraction back, you end up with this equation for y1. This one here, I'll do over here, y minus 4x is greater than or equal to 2. Add 4x on both sides. And again, remember, it's not 6 because one has an x and one doesn't. So that's 4x plus 2. You can go ahead and throw that into your calculator if you wish. Graph them both up. So I'll do that here. Down 2, right 3, just by doing it by hand. This is the part where everybody starts to make the mistake, right? Come back and check. This one is going to shade down. Eat the y, shade up. And then this one is going to be a dotted line, which again means that any point that is on that line does not count as a solution. Don't forget to write his name. Now I can go ahead and shade this guy down. Okay, there you go there. Now we'll do the other guy in red, 4x plus 2. It's going to look something like this, sketching it, trying to keep this. Okay, we're going to shade up, okay, because here we're eating the y. And we are going to make a solid line. And why is that? Because there's an equal to, there's a line underneath it. This one's going to have a solid line like this. This guy's going to shade up. And the solution is where the red and the black crisscross. There's your solution. And again, in this case, that point of intersection is not a solution because this dotted line, those points don't count. Okay. Moving on to number 3. Okay, again, same idea. Oops. Same idea. Let's go ahead and solve for y. So here's 2y plus 3x is less than or equal to 14. Subtract 3x on both sides. 2y is less than or equal to 14 minus 3x. So notice I did it a little bit different. The other one I did the x first. Here I didn't. I said 14 minus 3x. I wrote 14 minus 3x. Doesn't really matter. Divide everyone by 2. So that's going to be 7 minus 3 over 2x. And I am going to shade down. I am going to make a solid line. Okay, now the purpose of me putting this question here is to test to see if you remember this little trick. Here I'll first start by moving the 4x by changing his sign and writing negative 4x. Now I'm going to divide here by negative 1. Now if you remember, when you divide by negative 1 with inequalities, you have to switch the inequality. And there you go. There's that line there. So let's say, okay, he's going to shade up, and he is going to be dotted. So let's start with this one. 1, 2, 3, 4, 5, 6, 7. Down 3, right 2. Now this is a sketch. It's really pretty ugly. So make sure you do yours a lot nicer than mine. Shading this guy down. Y less than 7 minus 3 over 2x. We'll do the other guy again in red. Now I'm doing it by hand, but again, you can use your calculator. It'll probably be a lot easier. This guy is going to be dotted. Y is greater than negative 2 plus 4x. Oops. If you have 4x minus 2, it's the same thing. This one is going to shade up like that. and I would mark the solution area where the red and the black crosses with an S. Now this one has a second part to it, and what do they want to know? They want to know, is the point 1, 2 in the solution set? And, well, the solution set's more over here, so I would say no, because it is outside of the solution set, marked by an S. Okay, so that was the point of me always marking that, okay, because if I'm going to say it's outside of my solution set, they want to know, well, where is the solution set? And I mark that with S. Okay, so there you go. There you go. A quick rundown on graphing inequalities. Use your calculator as much as you can. Remember that shade up, shade down when you're solid, when you're dotted. Hope this video helps. If it did, hit the subscribe, like, comment. Have a great day, everybody.